cardiac pacemaker is a device used to ensure that faulty heart beats at a suitable rate. The required electrical energy in one type of pacemaker is obtained from using the energy released by a radioactive isotope. The radiation is absorbed inside the pacemaker. As a result, the absorbing material gains thermal energy and heats a thermocouple attached to the absorbing material. The voltage from the thermocouple provides the source of energy, electrical energy for the pacemaker. Part I, we've got to discuss whether the radioactive source should be an alpha, beta or gamma emitter. And part B, we've got to talk about the radioactive source needs to have a reasonably long half-life, otherwise it would need to be replaced frequently. Discuss the disadvantages of using a radioactive source with a very long half-life. Okay, so let's jump across. So the first thing it's told us is the radiation is absorbed in the pacemaker. Now, this immediately makes me think about the penetration involved. So we've got three sets of radiation we're going to consider: alpha, beta or gamma. And this is the least penetrating. This is the most penetrating. In terms of this is stopped by paper. This is stopped by a few millimeters of aluminium. And gamma is stopped by thick lead and concrete. Now, looking at these, if I'm going to put something inside my chest cavity, I'm going to want it to be relatively small. Now, to do that, I don't think coating it or having it within there, thick lead or concrete, is really viable to be able to actually cause the gamma to be absorbed. So, from that perspective, I don't think that's viable. Now again, the gamma, looking at the other end, would be easy to absorb. From that perspective, and the fact it's easy to absorb is good because it can't then get out of the pacemaker into my body. The beta is stopped by a few millimeters of aluminium. Now, okay, I could use lead rather than aluminium, but again, it's less easy to absorb. And therefore, it's going to be harder within a small device to actually capture it all, absorb it all, stop it escaping. So there, from that perspective, my preference in terms of the source, or what I'd be suggesting, therefore suggest alpha source, because less material needed to absorb radiation. So the device is smaller, which means I've got more chance of actually being able to fit it within my chest cavity. Okay, part 2. They say the source needs to have a reasonably long half-life, otherwise it needs to be replaced. And yes, I wouldn't like the idea of them opening up my chest cavity or anything along those lines to actually attach this thing to me. That's assuming it's internal. I guess they could have it external. Therefore, that makes sense. However, again, they're saying, well, disadvantage of using a radioactive source with a very long half-life. Now, thinking about it, this device will need a given amount of energy to actually work. And that means it's going to need a given activity needed to power it. Now, a very long half-life would mean that for any given amount of that material, it's going to be activity would be low. So a very long half-life means a very low activity. Now, the only way you could get around that then would be to have more of the material to make up for the activity. So if the activity per kilogram was half as low, you would need twice as much of the material. So more of the material would therefore be required to power the device. And I'd say potentially making the device larger. Which again, if they are actually putting it inside the chest cavity, might be an issue from that perspective. Hope that makes sense. Thank you very much.